This will be for the con exercise, exponential model word problems. Enzo is studying the black bear population at large national park. He finds a relationship between the time t and years since the beginning and the black bear population. B of t is modeled by this function. So B of t represents the population, okay, and t represents the time in years. According to the model, what will the black bear population be at the park in 25 years? All right, so this one's pretty simple. And it says round to the nearest whole number, so no decimal places. All right, so since they're asking for the population in 25 years, we know that t, since t represents the time in years, t is going to equal 25. Okay, and the population is represented by B of t. So really, we're just plugging in 25 into this equation. So it's going to be 2,500 times 2 to the power of 0.01 times t, which is 25. Okay, so 0.01 just moves the decimal place over 2 places on the 25. So 0.01 times 25, that's the same as 0.25. Okay, so that is the exponent on the number 2. So we just have to do this on the calculator. Let's try again. 2,500 times 2 to the power of 0.25. Okay, there you go right there. Don't use the calculator on con for these because it doesn't work too well. Use your own calculator. I highly suggest everyone get one. Okay, so they said nearest whole number, so you just have to look at the first decimal. If it's less than 5, you round it down, so we're looking at 2973. So click in the box, 2973. Does the answer make sense? Yes. We started at 2,500 and it increased. Number 2, the relationship between the elapsed time t and years since the closing of the mill and the town's population, P of t, is modeled by the following function. All right, so P is the population and T is time in years. In how many years will Sawyerville's population be 9,000, round to the nearest hundredth? All right, let's take a look. So basically, they say the population is 9,000. Okay, and we said P of t represents the population, so that's going to be P of t. And it says in how many years. So we said t is time in years, so we're plugging in 9,000 for P of t and solving for t. So in place of P of t, we're putting in 9,000. And that's going to equal 12,000 times 2 to the power of negative t over 15. Okay, that's just the exponent there. And we want to isolate the number with the exponent. All right, we want to isolate this, so I'm going to divide both sides by 12,000. Cancels on the right-hand side, 12,000 over 12,000. All right, and you could leave it like this, but just to shorten it, 1,000, we can divide top and bottom by 1,000, so cancel the 3 zeros. All right, and we're left with 9/12 times 2 to the power of negative t over 15. 9/12 equals 2 to the power of negative t over 15. Okay, now since this is base 2, I'm going to take log base 2 of both sides. All right, so I'm going to do log base 2 of 9/2, and I'm going to do log base 2 of the 2 to the negative t over 15. All right. Now, when the base of the log matches the base of the argument, the answer is just the exponent. So everything on this side canceled out except for the negative t over 15. Okay. So on the right-hand side of this equation, on this side of the equal sign, we just have negative t over 15. And on the left-hand side, I'm going to use change of base formula. So I'm going to do the log of 9/2 divided by the log of 2. Remember, change of base. The base goes on the bottom. Okay, and finally, solving for t, I'm going to multiply both sides by negative 15. So I'm going to multiply this side by negative 15. And I'm going to multiply this whole thing by negative 15. All right, let me clean this up a little bit. All right, just multiplied both sides by negative 15. And what happens on the right-hand side? The negative times negative is positive, and 15 over 15 cancels. So we're just left with t. I'm going to have to do this on the calculator. Negative 15 log of 9/2 divided by log of 2. All right, small mistake. I accidentally said 9/2. I meant to say 9/12. I remember we had 9,000 over 12,000. So let's do it again. Okay, negative 15 times parentheses log of 9 divided by 12, close parentheses, and that is divided by log of 2, close parentheses, twice. Okay, negative 15 times log of 9/12 divided by log of 2. Here we go. Okay, that answer makes more sense. So once again, you look at the third decimal, 5 or more, you round it up. So 6.22 becomes 6.23. Okay, so this was my mistake. I said 9/2 instead of 9/12. So just click in the box. 6.23 is the nearest hundredth. The culture of bacteria starts with 50 and increases exponentially. The relationship between B, the bacteria in the culture, and D, the time in days, is modeled by this equation. And how many days will the number of bacteria reach 800,000? Give an exact answer expressed as a base 10 logarithm. Okay, so we're not going to have an actual number for the answer. Our answer is going to be in terms of log. All right, so let's see. And how many days? So D is the number of days, and the culture of 800,000, the population, is represented by B, the number of bacteria. Okay, so 800,000 is just going to be B, and the number of days is D. That's what we're solving for. So in place of B, I'm going to plug in 800,000. All right, and that's going to equal 50 times 10 to the power of D over 2. All right, I'm trying to isolate D, so I'm going to get rid of the 50. This is times 50. Opposite of times 50 is divided by 50. Okay, I just do the same thing to both sides. 50 over 50 cancels. All right. And you can reduce this a little bit just to make it easier to write. Let me see. 80,000 divided by 5. Let's see. 5 into 80. 5 into 8 goes once. Carry the 3. That's 16. Okay, so 80 over 5 is 16. 80 over 5 is 16. And we have 1, 2, 3 zeros left. All right, so I just did 800,000 divided by 50. You probably don't even have to do that. You probably could have left it if you want to. All right, and that's going to equal 10 to the power of d over 2. And since the base right here is 10, I'm going to use log base 10 on both sides. And when it's log base 10, you don't have to write the base on the log. All right, no base, and it's automatically base 10. So I'm just going to do log on both sides. Okay, on this side, since the base of the log matches the base of the argument, the answer is just the exponent. That's d over 2. And that's going to be the log of 16,000. Solving for d, d is divided by 2. The opposite is times 2, so just do times 2 on both sides of this equation. All right, it cancels on the right, and we solve for d. So this right here is the answer. They wanted it in terms of log. So it's just 2 times log of 16,000. All right, so it's going to be 2 times log of 16,000. All right, you can use parentheses on the 16,000 if you want, but you don't have to. And this little dot is times. You can probably write the use the asterisk also. That's shift 8. Let me see. If you did shift 8, oh, they still give you the dot. All right.